All right, the last section that we're using in Chapter 10 deals with inscribed angles and inscribed polygons. Now, an inscribed angle is an angle that is formed without the vertex being in the center. Remember, the very first section we dealt with the vertex being that angle right there. And you'll notice that in this case, the inscribed angle, ADB, does not have the vertex as the center. In fact, the vertex is actually on the circle itself. So, the inscribed angle in this case is angle ADB. We label it just like we have other angles throughout the year. But then the other thing we're going to notice is we actually get an intercepted arc. And this intercepted arc is the arc that is formed by the inscribed angle. In this case, it's arc AB. Now, Theorem 10.7 says the measure of an inscribed angle is half the measure of its intercepted arc, meaning that an angle equals 1/2 the measure of the arc. So, if we apply this to what we know, we could say angle ADB equals 1/2 of arc AB. Now here's the one thing. Your inscribed angle could look like this example right here, where the center is inside the inscribed angle. The center would be about right here, and you can see that it's inside the inscribed angle. You can also have it so the center is on the angle or is outside the angle. The best way to know it is an inscribed angle is anything where the vertex is on the circle itself. This applies, this rule where the angle is half the intercepted arc applies anytime the vertex is on the circle. And we're going to practice that on the next page. In example 1, we're told to find the indicated measure. In this case, we're told to find angle T and the measure of QR. And that should probably be QT. We're going to back that up and we're going to make a little editing change. You can do this too. We're going to make that QT, not QR. And QT is right there. So, what we are going to do is we know the angle equals half the arc. We're going to apply that to what we know. If you look at angle T, we're given the angle and we're given the arc. In this case, the arc is 48. Well, the measure of the angle equals 1/2 of the arc. The arc is 48. Well, what's 1/2 of 48? 24. Which means that the measure of angle T equals 24 degrees. Let's look at arc QT. Still, the angle is 1/2 the arc. In this case, we are given the angle, not the arc. So, I'm still going to set this up. 1/2 the arc equals the angle. I'm given the angle. It's 50. And now I want to solve this for QT. If I multiply both sides by 2, the reason I'm going to multiply by 2 is to get rid of this fraction. You multiply to get rid of a fraction. If I multiply both sides by 2, the fraction will go away. 50 times 2 is 100. And I find out that the measure of arc QT is 50 degrees. Hopefully that's not too tough to understand. Let's look at Theorem 10.8. If two inscribed angles intercept the same arc, the angles are congruent. So, what we're finding out now, that is if two different arcs, or excuse me, two different angles, like in this case we have QRT and QST, notice that they both intercept arc QT. That both of those angles are going to be congruent. Which makes sense, because if they're both half the arc, they're both touching the same arc, the arc doesn't change lengths, so the angles should be the same. We're also told, in this problem, we can see that RTS and RQS both intercept arc RS. Well, if arc RS is 48, then angle RQS and angle RTS should be half of that. Half of 48, as we solved in example 1, is 24, and we see that they're both 24 degrees, which makes them congruent. Not too hard. Not really a whole lot of practice there. The next thing we're going to talk about is Theorem 10.9, which says that if a right triangle is inscribed in a circle, then the hypotenuse is a diameter. I'm going to stop there and I'm going to draw a diameter, and then I'm going to put a C in front of that, or next to that, and that does not mean the center, that means my C is as in my Pythagorean theorem. Okay? Then it's saying, on the other hand, if one side of an inscribed triangle is the diameter, then the triangle is a right triangle. If I draw a triangle inside this, and notice how all three corners of the triangle are on the circle itself, and if I say that one of those sides goes through the center, that triangle has to be a right triangle. Now I'm just going to label the other two sides as A and B, and then I'm going to draw where my 90-degree angle would be, just so you understand where it would be also. If you have a triangle inside a circle, go back up to here. Let's just draw a random circle, or a random triangle. Let's go from here to here. And then I want to make sure that I have one side go through the circle. Okay? I know that because this triangle is inscribed, meaning all three corners or all three angles are on the circle, and one of those sides goes through the center, meaning it's a diameter, that is the hypotenuse in a right triangle. Okay? Hopefully that isn't too hard to understand, because then we're going to apply that same idea to a quadrilateral. If a quadrilateral can be inscribed in a circle, or excuse me, a quadrilateral can be inscribed in a circle, if and only if the opposite angles are supplementary. What that means is opposite angles, angles that are on opposite sides, have to be supplementary. Let's label this guy X, this guy Y. What does supplementary mean? Hopefully by now in Chapter 10 you recognize that supplementary means they add up to equal 180 degrees. In this case, the opposite angles X and Y have to add up to 180. Any right or any quadrilateral that you draw, okay, we can take this piece out. Any quadrilateral you draw has to have opposite angles supplementary. This angle right here, which we'll label X, this angle right here, which we'll label Y, have to always be supplementary. And I want you to think about this. This angle, we'll call it angle X first, is an inscribed angle. It's half of this arc. this angle is an inscribed angle, and it's half of this arc. Now, let's say that in this case, your two angles make up the entire circle, meaning the two arcs add up to 360. Those angles can only be half of the intercepted arc. So even if x and y, the arcs formed, and let me highlight them so you can see what I'm talking about. Arc formed by y is right there. The arc formed by x is right here. Even if your two angles form the entire circle, okay, where there's no gaps, those two arcs would add up to 360. But the fact that an inscribed angle is 1/2 the intercepted arc, we'd have to say that 1/2 x plus 1/2 y equals 360. Well, that means that x and y would only add up to, if we take 1/2 of everything, would only add up to 180 degrees, which by definition is supplementary. Okay? So, if you draw a quadrilateral inside of a circle, just know opposite angles are supplementary. Let's look at example 2. It says find the value of the variables. Well, now here we have inscribed quadrilaterals. And I'm just going to list very quickly the variables that we have. We have an x, a y, and then we have an x and a c. And inside an inscribed quadrilateral, opposite angles have to be supplementary. Which means that if I add up x and 82, it has to equal 180 degrees. And if I take y and 68, it should equal 180 degrees. Real simple subtraction tells me that x equals 98 degrees and y equals 112 degrees. Now we can apply that same idea over here to the second problem, where 10x and 8x should be supplementary, and where c and 2c minus 6 are supplementary. I would like you to pause the video and solve for this x and this c right now. Pause the video and go ahead. Hopefully you had enough time to solve for both x and c in our second problem. And you can see my work here. To solve for x, I combined my like terms. 10x and 8x gives me 18x. Then when I divide both sides by 18, I get x equals 10. To solve for c, I do the exact same thing. I combine my like terms. C plus 2c gives me 3c. And I actually moved 6 to the other side by adding 6 to both sides. That's how I got 186. When you divide both sides by 3, you get c equals 62. Now, if you take a look at the next page, you're going to see that we're ready to go to our homework now. Quick review shows us intercepted angles, or inscribed angles, are half the measure of their intercepted arcs. That inscribed angles that touch the same arc are congruent. Right triangles formed inside of a triangle have the hypotenuse as a diameter, in this case our c. And quadrilaterals inscribed in a circle have opposite angles supplementary. And we're going to take these same ideas and look at our homework now.